Um, well, welcome to sunny Brisbane. I'm very fond of Brisbane, so it's wonderful to be back here, and welcome to International Data Week and our session on the highs and lows of providing digital infrastructure to enable safe access to sensitive data for research. We've got a fantastic group of people here. I think we're going to have a really good time discussing all the challenges and current approaches. So my name's Dr. Esmond Urwin. I'm a digital health researcher at the University of Nottingham in England, and I do a lot of work around OMOP, especially context representation, so I'll be your chair for today. And without further ado, I'd like to hand over to Tim Beck at the University of Nottingham in Glasgow today. So Tim, over to you, please.
Thank you very much, Esmond. Hopefully you can hear me and see the slides.
Yeah. Yes.
Wonderful.
Yeah, good.
Great. Wonderful, thank you. So hello everyone. My name is Tim Beck, as Esmond said, from the University of Nottingham. Welcome again to this session. Unfortunately, I couldn't join you in Brisbane. I'm at another conference in Glasgow. But with you in Brisbane there, you have my co-chair and colleague from the University of Nottingham that you've just met, Esmond Urwin. So I'd like to start by acknowledging the traditional owners of the land that we're meeting on today in Brisbane and pay my respect to their elders past and present. So I'd like to remind you that this session is being recorded and we will be following the International Data Week 2025 Code of Conduct, which is available from the conference website. So I'm going to take you through a few slides now to introduce you to the session. We'll then have some questions for all of you to join in on using Slido. This will be an icebreaker and help get a sense of who is in the session today. So watch out for the Slido QR code and the link, which will be coming up shortly. So our aims for the session today are to set out the international landscape of digital infrastructures that enable safe access to sensitive data for research. So we will also explore the highs and lows of providing this type of infrastructure. And we'll be hearing from international experts in this area during some short talks. Then there'll be a panel discussion where there'll be the opportunity to ask the speakers any questions you may have. And most importantly, our aim is that everybody enjoys this session. So when we talk about infrastructures that provide sensitive data for research, we're talking about controlled computing environments such as trusted research environments or secure data environments or secure processing environments or data safe havens and so on. So these environments are designed to allow researchers to work with sensitive data such as health data or financial data or administrative data, but work with this data in a secure and ethical manner. So they use strong user identification and role-based access controls to ensure only authorized individuals can access the data. Data is de-identified or anonymized before access, and users can only access the minimum amount of data required for a particular research project, and user activity is logged for monitoring and auditing purposes. So these environments are subject to strict technical and legal demands. So users work within lockdown virtual machines or remote desktops with no direct internet access. So users cannot bring data in or out without permission, and any results are reviewed for disclosure risk before they are released to the users. And then finally, there needs to be some level of standardization across these environments to make it easier for researchers to conduct federated analyses across several of these environments and across different jurisdictions. And so this is an area that we're going to explore during this session. So the speakers that we're going to hear from today are members of the International HealthWise Consortium. So HealthWise is formed around a common understanding of how to conduct international data analyses that maintain confidentiality and privacy, ensure data can be utilised in research to further our understanding of diseases, and emphasises global collaboration and use of standards. So the HealthWise Consortium is guided by 3 principles of enabling, empowering and equity. So HealthWise enables global insights and research so that we can learn from the global healthcare systems. It empowers governance such that it remains in control whilst enabling, and it ensures that those that are currently excluded can become enabled and empowered through the 3rd principle of equity. And so if you want to find out more about the HealthWise Consortium, we have a website. The URL is there on the slide. So after the Slido questions that are coming up, we're going to move to talks from our infrastructure providers. We'll be hearing from experts from England, Australia, South Africa, Wales and Singapore. And the talks will help to set the scene for us. We will then move to a panel discussion with the speakers, where there'll be the opportunity to ask your questions. So for those in the room, there'll be a roving mic, so you can ask your questions in person. You can also use the app, the International Data Week app, to ask your questions. And if you're online, you can also ask questions through the virtual platform. So Esmond and Andy will be moderating the discussion and the online questions. Okay, so this is where we would like you to get involved and share your thoughts on the topic for this session. So please go ahead and scan the QR code or go to slido.com on your device and enter the numeric code 5606 386. This will take you through to a poll. I'll just wait a couple of moments to give people a chance to join. This is will just be an icebreaker and just find out more about who is in the session today. You don't need to register on Slido or have an account. This can all be done anonymously. So yes, if you have a device there, please scan the QR code or go to slido.com and enter that numeric code. Okay, so there's still chance to do that. And so this is the first question as an icebreaker to find out who is in the audience today. So this is, the question is, without using the title of your job, describe what you do. So I'll leave this up for 20 seconds or so. You've still got time to join using the QR code or going to slido.com and entering that numeric code. This is great. We've got 20 people, 19 people entering information here, so we can find out more about who is in the audience today. Glad to see lots of people that are working with data and providing data and infrastructure. It's wonderful. We've reached 30, over 30 now. Okay. This is great. Okay, so this is really good, giving us an overview of who is here today, social science as well. Great, okay, so we'll move on in the interest of time. This is great, we've almost got 40 participants on this. We'll just move on to the next question, which is, which words come to mind to describe the highs or the benefits of providing or using sensitive data for research? So this is going to generate a word cloud. So feel free to submit more than one response here. So we're interested in all types of sensitive data that you may work with. You can come at this from the perspective of an infrastructure or a data provider, or from the perspective of a data user. What do you see as the positives of making sensitive data available for research or having access to sensitive data for your research? And so I'll leave this up for another 20 seconds or so. So we're interested in the different perspectives from members of the audience. These are topics that will be touched on by our speakers. and during the panel discussion. So trust is key here, and reuse. Responsible reuse, excellent. Okay, we're almost at 40 again for this question. Great, excellent. So I'm sure these are topics that will be touched on by our speakers. Moving on to the next question then, and this is the final question. Which words come to mind to describe the lows or the challenges of providing or using sensitive data for research? So again, come at this from the perspective of an infrastructure provider or a data provider, or from the perspective of a data user. What do you see as the negatives of making sensitive data available for research, or the blockers that make it difficult to use sensitive data in your research? And so I'll leave this up for another 20 seconds or so. We need to move on. Yes, risks, cost, governance. Excellent. So we're at 40. Thank you, everyone. I'm sure these are topics that were brought up by our speakers in the panel discussion. I'm sure will be questions that can be raised during the discussion. Excellent. So we're over 40. That's great. Thank you. So thanks for sharing your views on the topics for this session. We're now going to move on to presentations from our speakers that will touch, I'm sure, on many of these points that have been made. And this session will be chaired by Esmond.
Tim, thank you very much. That's wonderful and insightful. Okay, I'd like to introduce our first speaker. It is Professor Phil Quinlan. He is Professor of Digital Engineering and Health Informatics at the University of Nottingham in England, United Kingdom. So, Phil, the floor is yours. Thank you.
Thanks very much. So I thought I'd give you a little introduction to University of Nottingham. I think most people, when you say Nottingham, either think of Nottingham Forest or Robin Hood. But we do other stuff as well. And we are a part of a global network of universities. There is an official Robin Hood as well in Nottingham if you ever come and visit. But there's a really interesting image on there. It's the power of the prototypes. If you ever come to Nottingham, you'll hear that we're the home of the MRI. And this was the prototype of the MRI. And what I thought was really interesting was that the reason that the inventors got the Nobel Prize was the conversion of signals to images. That's what makes the MRI special, is that conversion of raw data into data that people can actually action and use in lives to help people. So we're part of the Centre for Health Informatics. We're quite a broad range. To give you an idea, we have a group called Primus that do a lot within our primary care sector. So that's when you go and see your general practitioner. But really, a lot of what we do is software. So we build software to change the infrastructure. So we do the science of the infrastructure, build new software to help enact change. And that feeds through into multiple different programs. We're involved in the NHS Secure Data Environment Programme, which is a new initiative to make data available at scale across the UK. We also apply that into our local NUH Trust, which is an NHS organisation where we try and change how they're making data available, building the necessary plumbing to make that data flow. We're also involved in European programmes. Despite Brexit, we are allowed to still be part of European projects. One's called Entrust, which is around the blueprints of how do we enable research across the European Union and wider. So it's really understanding the building blocks that we're trying to put in play to enable federation to occur. And we're part of Health Data Research UK. That's one of our kind of home organisations. It's the UK's National Institute for Health Data Science. It's a big part of what we're doing. But more recently, we've got another one called DARE UK. So HDR UK is very much about health. DARE UK is about across the board. So it's the health and wealth. It's into a whole variety of different sectors so that we can integrate data between different domains. And we get a lot of support from the NIHR, it's the National Institute for Health Research, an NHS funder, around our Nottingham Biomedical Research Centre. So this is our beautiful campus. We're based just there, right next to the hospital. It's a great campus to work on. So it's time we need to reclaim the F word. And I know what you're all thinking. Federation, right? So independent organisations working together through agreed upon standards and protocols while keeping control over their own data services or platforms. Why we're trying to reclaim this is when we talk about federation, we often get stuck in what type of federation? Do you mean eyes on? Do you mean eyes off? Do you mean visiting? Do you mean sharing? Do you mean pooling? And there's so many different technical ways of achieving federation. And we get very stuck on the technical part rather than the wider aspects that need to be achieved to get federation to work. So we frame this in terms of what's possible, acceptable, and useful. So technology helps define what's possible. That shows you what you could do. But just because you can do something doesn't mean you should, or it's the right way of doing it, or it's acceptable to trusted research environments, or that it's acceptable to the public. And that's a really important aspect to factor in. What's acceptable actually helps define what's possible. But just because we can build some clever tech doesn't mean that researchers actually want to use it or find it useful in their research. So it's a real blend of what we have to look at. What's possible, what can be done, but making sure we're doing that in an acceptable way and providing something that's actually useful to the research community. But the hard part of what we're doing right now is what's acceptable is changing. In the UK, you used to be able to get data sent to you. That's changing. Data is going to be put in trusted research environments. It's a lockdown environment. You only get access to the data that you've been given permission to. So that's a policy change that's defining what's acceptable. By that significant shift in our national policy about the use of trusted research environments, that's changing what's possible. The risk, though, we can really scare researchers when we start talking about what's useful in that context. If we approach them with all the technical details about all the different ways that you could possibly do federation, it makes this sound really hard, really difficult, and it's just going to get in my way. This is yet another thing I have to try and navigate in order to get my research done. This is not good. And we rarely hear a researcher say, do you know what I really want you to split the data off into different environments and make it harder for me to access it. That's usually not what, when we talk about useful stuff, isn't there. But it's very understandable why it's needed from an acceptability point of view. So coming to Dare UK, they did some amazing work looking at the impacts. What they did is they got people into a room and said, do not talk about data governance, do not talk about data security. What could you do if we sorted out the data linkage between different environments? Then looked at only a handful of use cases, and the potential impact to the UK economy is huge if we get that right, and that only scales as we go beyond. So it's incredibly important that we don't worry people about the technical approach, inspire them with what could be possible if we get it right. So although we're part of a federated analytics program, we've tried to rebrand and call ourselves federated research. It's that more encompassing term. And really what we're trying to drive here is adopting standards. There's so many data standards out there. There's so many standards that describe how you could do different types of analytics. We don't need another one. The standards that exist today are perfectly suitable for what we do. We just need to get better at using them and adopting them. By doing that, we can build trust. Standards are a fundamental way of building trust, whether it's describing what a TRE is, whether that's a way of having a data standard to describe the data. Trust is a fundamental element when we're trying to build these federations. So if we get that right, we can enable the federation. We don't need to build federation, enable federation. And by doing that, we can accelerate research. So we do a lot of work on OMOP, but it's not loved. Mainly because for some TREs and for some data controllers, this is yet another standard that they're being asked to adopt. There's a learning curve to adopting OMOP. You have to learn about it and how to do it and how to do it correctly. Also, there's there's copies of the data that you might have to undertake. So you've got your raw data, and then you have to create a new version of that data and have that in OMOP. But also for researchers, a lot of researchers just want access to the raw data. They don't want this converted set of the data, particularly when the rules and the conversion rules are not understood or known. How did you generate that OMOP data set? Don't know. Not sure if I want to use it anymore. So we have to understand, common data models are great, but how do we get people to adopt them? And that's something that we do a lot of work on in Nottingham. So Esmond talks about context a lot, so I had to have a slide. He told me you can only talk if you have a slide about context. So I've got a slide about context, and it's going to explain what happens next. So in ARDC, which is the entity around standards, they have White Rabbit, they have Rabbit in a Hat, and they have Usagi, which apparently Usagi is something to do, it's Japanese for rabbit. So we joined in. We've got lettuce, carrot, and bunny are our software tools. So lettuce and carrot are very much about trying to help people to adopt OMOP. One of the challenges is finding the right concept. So you've got your source code, you need to find the right alternative. Lettuce is an LLM, a large language model, that helps you find the right code for the data that you have. Carrot is then a tool to enable you to share and have a provenance of information about what was the source term, what was the term you used, and capturing that in a way so you have that mapping available. And importantly, you can share those, and you can have other people reuse those mappings. So we're trying to reduce the burden of people adopting OMOP, which is really important. Really important of all of this, open source. So these are open source tools anybody can use, and anybody can contribute to. So we have contributions coming in internationally. Bunny, this is a tool to allow you to ask questions of the data. So once you've got your OMOP data set, you can ask a question: how many patients do you have that have condition A or treatment B? This has been developed, co-developed between us and multiple entities in the UK. Open source, again, in England, we have the SE network. Nearly all of them are adopting this. Simon, who's online, we presented soon, is also trialing this within the SAIL platform. And the way this works is, locally, you have a data set, an OMOP data set, you install Bunny, and that talks to the outside world where people can log in, create their query. We did this in partnership with industry. So a company called BC Platforms created that central view, that central system where people log in, creating that useful interface for people to search. But locally within each TRE, there's software, open source, people can inspect it, and see how it works. And we're really starting to build the scale. We've got this running on CPRD data, about 40 million people, and multiple other data sets available as well. So last slide, QR code, you can take them away. So it's through to our repos for bunny, carrot, lettuce. We've also got a survey on there as well, if you want to take a look. All the slides, this took me ages, but all the slides have got images from our beautiful campuses across the world. We've got 3 campuses, one in UK, Malaysia, and China. Please come and visit at least one of them. We'll be very happy to host you. Thank you very much.
Dom, please. Wonderful. Thank you, Phil. Our next presenter, Dr. Dom Gorse, he is on home territory, Director of Data Science and Collaborative Research Platform at the University of Queensland here. Dom, the floor is yours, please. 10 minutes. Thank you.
All right, so I will present today a journey of enabling access to the Queensland Health data for research purpose. And this is the work of Professor Claire Sullivan, Jason Ferris, and I'm presenting. But first, I would like to acknowledge the traditional owners on the land on which we are meeting today, the Turrbal and Niagara people, and I pay my respect to their elders, past and present. So there is a lot of data collected every day in hospitals, and this provides real-world evidence for research, and researchers at universities are very keen to access that data. And this could be for developing dashboard, or for developing AI model, or just traditional research. Now, this is quite a challenge, because there is a lot of reason why getting data from hospitals is difficult. There is legislation, there is privacy concerns, and people in hospitals are busy running hospitals, and they don't have time to extract data or transform data for research. So here in Queensland, we are very lucky to have just one system. So all the hospitals are using the Cerner system, and this is deployed across all Queensland. So right now there are over 70 sites, and more sites are coming on a monthly basis. So this is quite a unique opportunity because we have data from regional Australia, we have data on First Nation people, and so this represents quite an important source of data for research. So what we've done to enable this access to clinical data is to create what we call the Smart Hub, which is a team that is able to work both across Queensland Health and the university. So we have a team with having co-joint appointment within Queensland Health, and can have, they have the time and they have the resources to be able to extract data and provide the data for research. So the team is led by Jody Austin, and it has been in place for now several years. It has taken a long time to get those conjoint appointments and to get this agreement between Queensland Health and UQ to have conjoint appointment. But since 2023, this is now in place, and the Smart Hub team has been making more and more queries and more data access. What has been very important is that co-location, so there are days where they are at Queensland Health, there are days where they are at UQ, but very importantly, they are operating under the Queensland Health policy. So even if they've got access to the data, they're not going to give it to you. They will have to follow the process. The value there is that they are very well aware of the process. So no, it's really speed up the process of getting all the approvals to access the data. And the team has a mix of skills from data engineers, clinical informaticians, and data governance. So this is where we are. Within Queensland Health, all the data, clinical data is captured every day in the Cerner IEMR. And what we are doing is to extract the data and convert that to OMOP, and then bring that data within a trusted research environment. So OMOP has been just mentioned before. This is a good way to standardize how the data is stored within a database, but also to standardize the data itself. So why are we doing this? It's really to simplify and make the data research ready. So Cerner is a very complex system, more than 8,000 tables. Not all of them are used every day, but there are a lot of tables. And it's very complex to extract data from the system. On the other side, we have OMOP, which is only 39 tables there. And it is standardized. So if I do a query here in Brisbane and do a query at Nottingham, that's the same query I need to do. So this is the process of converting the data from here Cerner to OMOP. We have to design the ETL. We have to map the code to the standard concept. And then we have to implement the ETL, do the quality control, and so on. So it's different people doing this. We have data engineers, but we also need the domain knowledge when we do the conversion to the standard concepts. Now, to do that, also we need to ensure that governance is good. So we have here both Queensland Health and University of Queensland oversight over the project, and we have the ability to work with specialized group within Queensland Health when we do the conversion. So SmartHub has been operating for a few years now, and you can see that we are already providing data for research purpose. It's not just for UQ, it could be anyone. We have a cost recovery model, but this is like a national service. All right, I will speed up now. So the next step is we have the data. How do we give it to the researchers? And this is by using a trusted research environment. So a theory really is about enacting the 5 safes, making sure that the project is safe, the people, the settings, the data, and the output. So we have the UQ theory, trusted research environment, and we say no one gets in without the permission, and there is nothing in and out without permission. So a theory here, the UQ theory, we have what we call a vault, which is a virtual desktop, and the researcher who is approved can access to the vault. Within the vault, they've got access to a Windows machine, and they have the data they can access, the tools they can use, and then what we have the data steward approving everything that gets in and out. The system has been designed to be very scalable. So in this theory, it is the data steward or the vault steward that has the ability to manage all the governance of the project. It's not us. We are leaving this to the researcher to decide what is proper to get in or out. So we are using this in different projects. First, we have the Eden Australian Health Data Evidence Network, which we are just starting. This is in collaboration with the ARDC and University of Adelaide. And 2 minutes. And this is now about mapping all the IMR sonar to a map. The other project is the NINA, the National Infrastructure for Federated Learning in Digital Health. So here we have 7 sites across Australia, 23 partners, and we are working on 4 diseases. So you can see Queensland Health in the middle is one of the key sites, and we are doing a different type of federated learning. And the third one is Healthwise, that was just presented by Tim. All right, so we just finished by acknowledgement of the team, both the SmartHub team in terms of the data access, and here at UQ, the research center who is providing the infrastructure for the theory. Thank you.
Thank you, Don. Merci bien. C'est gentil. Okay, right, sorry, speak French. Any chance? Okay, our next speaker is Dr. Sumir Panji. He's Program Manager at the UCTC Bio at the University of Cape Town in the lovely country of South Africa. So if we could swap the shared screen, that'd be wonderful, thank you. Sumir, 10 minutes, the floor is yours.
All right, sorry, I just want to see, can you see my slides? Are my slides visible?
Yeah, can you put them in presentation mode? Swap displays.
Let me just swap displays. Sorry, just give me a second. I've got 2 different displays over here. Just give me a second. Go and you switch off my camera for a second while I do this. Share. Okay, swap displays. Okay, is that working?
No, we see your sort of design view.
Oh, okay.
Where is it? Where is it?
Press swap displays at the top.
Yeah, swap displays, top left. No,
Okay,
Simon.
yeah,
Hi, Simon. Slightly early.
sorry, we've got two different screens over here. Let's just do this. Okay, so if I put this in full view.
Yeah, try that.
Okay, and now?
Yeah. Click now. Super
Does that
duper.
work?
Thank you. Samir, floor is yours, 10 minutes.
Okay.
Thank you.
Alrighty, sorry, I can't see my thing to switch on my camera. Okay, sorry, let's try and get to Zoom controls. Okay, just in the interest of time, I'll just continue with my camera and switch it on quickly.
Yeah, that's fine.
As soon as I finish. So first up, I'd just like to provide an acknowledgement. We acknowledge and celebrate the first Australians on whose traditional lands we meet and pay respects to the elders past and present. So my name is Sumir Panji. I'm part of Prof. Nicky Mulder's group at the University of Cape Town and the Computational Biology Division. I'm grateful to the organizers of this session, the HealthWise Consortium, for giving me a chance to talk about some of the work we're doing as part of the eLwazi Open Data Science Platform in terms of making Africa data more discoverable and interoperable. So the Data Science for Discovery and Innovation in Africa Initiative, or DSI Africa, is an NIH-funded program that aims to leverage data science technologies to transform biomedical and public health research and develop data science solutions to contribute to the improvement of global health outcomes. The vision of DSI Africa is to create and support a robust pan-continental network of data scientists and technologists that's equipped to apply advanced data science skills to transform health. The DSI consortium comprises of 20 research projects with 7 large multi-country research hubs, many that are integrating diverse data types ranging from health and demographics to wearables. There are 4 LC projects working with the research hubs and projects to better understand and navigate the legal and technical aspects of cross-border data sharing. There are 7 data science degree education programs and the eLwazi Open Data Science Platform. The DSI consortium has a footprint of 350 members in 21 African countries. This is just a slide just providing a range of the data types the DSI projects are collecting, and a lot of the data they're doing is they're integrating existing data sets to create newly inferential data sets, and in some cases they are generating data sets as well. The data ranges from genomics, climate change, pathogen surveillance, imaging, and verbal autopsy data. And many of these data types actually are clinical and have identifiable where human subjects are involved and require ethics approval. The eLwazi ODSP program consists of 7 African partners, 3 US and 1 UK based, and it aims to provide a flexible, scalable, open data science platform for the DSI African Consortium to find and access data, select tools and workflows, and run analysis on the choice of computing environments. The solution needs to be feasible, flexible, and scalable within an African context, and enabling the implementation of data science for discovery and analysis of health data, and at its core, open standards need to be adopted from the outset to ensure interoperability. eLwazi supports the DSI consortium in a number of ways, from data management, developing data models, mapping the data to OMOP models, creating data harmonization tools, and cleaning and mapping tautologies. We also assist projects in terms of reproducible science by containerizing their tools and also placing analysis scripts in workflows to enable reusability. And we also provide some access to compute infrastructure for the DSI projects, such as on-prem or cloud-based, and we're working to implement some of the J4J standards at one of the sites. We also do quite a bit of training as well for the data science programs, and that includes like train the trainer or hackathons or data science skills and courses. We aiming to make use of the data biosphere concept, whereby one can discover and search for data through portals, be able to move the data to analyze in workspaces such as your secure development environments, and also be able to use tools and workflows from repositories. It needs to be modular and composed of functional components with well-specified interfaces. It needs to make use of open standards and developed under open source licenses, as mentioned by Phillips, to enable extensibility and reuse. And it should be standards-based and consistent with standards developed by coalitions like the Global Alliance for Genomic and Health. Overall, a user should be able to come into a central portal metadata catalog, search for African data sets, obtain information as metadata, its location, its data use, access, and conditions. The user should be able to access the data file available in a cloud bucket or on-prem, virtual workspace where they can select the computing environment and run tools and compute on the data and export the results. So as part of the eLwazi project, we have a data support working group whose broad mandate is to enable greater data reuse across DSI Africa by supporting the DSI Africa data hubs to share the data as part of the eLwazi platform. and in the most interoperable form as possible. And this also includes building a community of data stewards and managers that are using tools for data harmonization and getting practical experience in making the data fair. So one of the largest projects we have in eLwazi is to make the DSI data fair. We also want to develop a community of active data stewards in the process. So we've worked individually and collectively with the DSI Africa projects on data harmonization and determining suitable data models and metadata standards for interoperability, as well as also determining the FAIR goals and for building a eLwazi metadata catalog. So working in research projects, we've helped them define the conditions of data reuse and mapping it to the data use ontology and to determine the FAIR maturity level and work with them to improve the fairness of the data sets. We've used the FAIR Plus project, which has produced a reusable verification framework. This framework includes tools and guidelines for making life science data fair. And the main tools that we use are the FAIR Dataset Maturity Model. This is a tool that helps organizations analyze or plan the progress in creating and maintaining fair data. The model is comprised of 3 categories of requirements, and these requirements are prescribed by a set of indicators, which is your content related, what's reported in the data set, is it mapped to ontologies and the metadata, and what are the data reuse conditions. Representation and format is how is the data stored, is it in PDF files, is it in TEX files, and your hosting environment capabilities is, are you able to access the data through APIs? So to accomplish the verification across diverse data sets and projects, we decided to build a community of data stewards from the outset within DSI Africa. Each research hub or project has a data management analysis core that is responsible for integrating various data sets with the projects and has data managers and stewards as part of it. So we've been hosting an annual data jamboree, actually we started in 2022, which was virtual and it's been carrying on, which has been focused on actually getting the DSI Africa data sets fair, as well as harmonized. We followed this up in 2024, where we actually did establish a baseline of fairness for each of the projects and where they'd like to be, and we've worked with them to apply recipes to a fair cookbook to help the fairness of the data. And this slide just gives you a snapshot of the different needs for the different projects in terms of the verification goals. And as you can see, they're quite diverse right now, and this could be just reflecting that different projects have different needs in terms of where they are and the progress. So this method gives you a catalog that we have created for the different DSI Africa projects to log the data sets in. It's a work in progress, but we have to have complete coverage for all the data sets by mid next year in there. But this catalog aims to make the DSI Africa more discoverable due to the metadata and data fields which we're collecting, which are structured, and we want to integrate them with GA4J standards. So I'm just going to talk a little bit more about the infrastructure side now. And the current challenge that we face in Africa is the proliferation of data protection legislation. This makes it very tricky for cross-country collaboration, especially around demographic health and genomics data. And this is a nice widget created by the DSI Law project that allows you to compare different data protection laws in different African countries to decide if you're allowed to calibrate or not. So the standards we use are from the Global Alliance for Genomics and Health, which was formed in 2013, and is an international community dedicated to advancing human health through genomic data. A large part of the GA4J's work is to develop interoperable standards to enable the responsible data discovery, sharing, and analysis across numerous computing environments. These GA4J standards provide a framework that enables remote computational services and analysis without the need to move the original data around, so it kind of enables federation. And these are I'm just quickly going to go through some of the standards that we're using. The first one we're using is the Data Repository Service, which provides a standard set of data retrieval methods that are agnostic to the underlying computer infrastructure. We are using Data Connect, which connects researchers to information and data sets regardless of how the data is originally stored or formatted. We're using the Workflow Execution Service, which is a protocol for running the same analysis on genomic data in multiple cloud environments. And we're using the authorization and authentication infrastructure, AI or passports, to enable secure data sharing from different countries and allow people to access the data. The GA4J standards can be extremely daunting when first looking at them, as they're quite an established community. And the challenge we face in eLwazi is how to get a grip on these standards and how to implement and test them in a consistent framework while developing expertise in these standards. So in discussion with the GA4J community, we decided to work with the GA4J starter kit as a starting point. To get a hands-on experience and practically implement the standards, we hosted a GA4J hackathon in 2023, where we had some of the community experts come down and worked with some of the research software engineers in eLwazi and the DSI Africa projects. The aim was to set up the starter kits and expose use in production and better understand the implementations. As an outcome from the 2023 hackathon, we ran a pilot project to determine if you can use the standards to find data with a query, use that query to then submit the analysis job to a web server located where the data was found. We had a starter kit installed on 4 sites within Africa as part of the pilot. That's Elifu, South Africa, the ACE Labs in Uganda and Mali, and the Uganda Viral Research Institute in Uganda. We used a region of the ACE2 genes from the 1000 Genomes projects into 4 batches, with each one hosted on a different site and made accessible with the DIR server. So the user would query the Data Connect server, get a list of DIRS IDs, select the DIRS CRAM object based on the IDs. These DIRS IDs are submitted to West points at each of the sites that contains a portion of the data to run some of the analysis on the 4 individual objects, get some stats, and then aggregate the results into a combined multi-QC report, which is sent to the user. So this project does show it's possible to enable federated computed analysis in different nodes in Africa using the J4J standards on-prem. As a follow-up, we decided to host a hackathon earlier this year in August 2025 and move the SolidKit implementations to production-ready implementations. The plan for this hackathon is inclusive. At the start, we started with 15 members, and towards the end, we had 40. And I think this shows the interest in J4J standards. And interestingly, we had a 4th stream, which we added this time around, which is the implementation of J4J standards in trusted research environments. The first day of the hackathon just consisted a lot of talks, so we just made sure we don't duplicate work between the different streams. And the hackathon ran over 5 days, and we actually moved the solid kits to more production ready, and we've integrated the DNA stack. There's a lot of energy and enthusiasm, and we're lucky to be working with a commercial company, because I think for us it's also important as Africans to develop capacity in these regions to use this technology, because if the world is using this technology, we as Africans should also be able to use this technology for our day-to-day assets as well. And I think it's quite important, especially in a global context, if you want to work with groups like the HealthWise Consortium that are all using interoperable standards and the same kind of trust and federation. And just a quick plug is that it's not only data stewards and research software engineers, we're also training end users in terms of reproducible science, and we're running a containers and workflows workshop at the end of November. So with that, I'd just like to thank the eLwazi team and the PI, Prof. Mulder. Thank you.
Sumir, really, thank you very much. Okay, next presentation, Professor Simon Thompson, Professor of Health Informatics at Swansea University, Wales, in the United Kingdom. So if we could just swap over to Simon, super duper. Simon, thank you. The floor is yours, 10 minutes, please.
Thank you very much. So obviously I'd like to pay my respects to the first Australians whose traditional lands we meet, and we pay respects to their elders and past. So I'm the director of the Sale Databank, and I think lots of people know about the Sale Databank, so I won't dwell on it too much. But it is the trusted research environment for Wales, which is part of the United Kingdom. We have 100% coverage of GP data and laboratory results and secondary care, tertiary care, etc., and about 87% of all GPs. But more importantly, we've also got non-health. So we've got schools, education, justice, census, tax return, climate, environment, social data. So it's to kind of get the holistic picture of a population. It's very mature. It's been running for 15 years. And I think that maturity is what leads to most of the success of the Sale Databank. So I guess, so what? I think this is an interesting slide because we get about, we've been running 15 years, but this is a report from the last 5 years. We get about £1 million in UK money a year by the Welsh Government to run this, but the actual cost is 2.8 million per year. And we cost recover 65% of all the operating costs of that trusted research environment. But that has resulted in £189 million in the last 5 years of research income, of which 55 million has gone to the country of Wales. So if you like, the return for investment on for running that trusted research is very good for the Welsh Government. 55 million coming in and about 131 jobs created. The other thing is during the COVID pandemic, we were very successful because we were running 35% of all the projects across the UK, and yet we're only 5% of the population of the UK. And we got our turnaround time down to 6 days from application to access to data. It's back up to 5 weeks now because it's kind of like it's a cost thing. But we couldn't have done that if we hadn't have automated so very much about the system. We didn't hire 100 more people. The system was basically turned up to 10 and off we went. But Wales also runs this thing called SERP, or Secure Research Platform, which is born out of SAIL originally, but is actually a big endeavour already. So for us, there are different definitions of trusted research environments. Some people's definition is one project, set of users, some data sets, and that's a trusted research environment. And that's fine, no problem with this. That's not our definition. Our definition is many users, many projects, many data sets all together under a governance wrap. So we're running 29 trusted research environments in the UK, but we're also running ones for Curtin University, Monash University in Australia, and we run one for the Government of British Columbia in Canada. So that's the same thing. So if we look at the UK context, that means our infrastructure is supporting, last week, 1,621 people connecting at any given one time for 29 trusted research environments. And as you can see from this diagram, they're not all born equal. Dementia Platform UK and the Sale Databank and some of the others are much bigger in their operation than others. But also you see the multimodality of data here in the fact that we've got imaging, genomics, non-health, health, cohort data, etc. This doesn't include the Australian trusted research environments or the Canadian ones or Northern Ireland or the island of Ireland. But there are a lot of consequences to running a trusted research environment. It's a big endeavour, front of house staff, help desk, even application process. You can have an application process and it can be as clunky as you like, it doesn't matter. But when you're running hundreds in concurrent, you need real systems for that. Data acquisition, there are over 600 data sharing contracts and the whole workflow of that is super complicated. And then there are complexities about multimodality, cohorts and the EHR data are very different, but free text, imaging, genomics and bioinformatics are even more different. Output checking and egress is a big process. But I think the biggest challenge is, as a university, we need to act like a business and have a business mentality because we have users across the world 24/7, and yet we're in an academic institution. But SERP is always evolving. So we have tenancies, which are trusted research environments, but increasingly we've got this thing called hubs, which are basically trusted research environments inside trusted research environments. An example of these is DataMind, which is a £10 million trusted research environment. It's inside the Sale Databank, but it has EHR, cohort, NLP, imaging, genomics. It collects data on REDCap, XNAT, Cognitron, etc., etc. What it's done is it's kind of gone inside another trusted research environment. So the activity of running a trusted research environment is taken care of by Sale, and they focus on the science. Traumatic brain injury, TRE, also did the same inside Dementia Platform UK, but it was a £6.8 million project. It went live 1 week after funding because it didn't have to establish all of the governance and the policies and procedures. And increasingly, we're giving collaborative space, which is giving the data providers back a trusted research environment to do their thing. So there are 6 of these, and as 2 cohorts have abandoned all of their own infrastructure and are only using trusted research environment for their own analysis, their own data. We're constantly changing. We're going to go through these very quickly. We are working with, the slides will be shared after, working with a national platform in the UK for what defines safe people. In Canada, they've got health, non-health, and they've got First Nation data. And the law is really different for these. So we have a trusted research environment that obeys the law, and we share the same data in a very, very different way into the 3 different environments. Phil talked on Carrot. We're adopting Carrot and international standards and working with Nottingham to get all our TREs to OMOP. Advanced linkage going forwards. We also do geospatial linkage, and again, we've presented in many conferences about this. We're also working across the UK on a working group for defining synthetic data, and we're coming to Australia at the beginning of next year for a road trip on this. But we are now funded for free of the 29 TREs we run in the UK to have a fully synthetic version of the trusted research environments to support training and early access, as well as AI model development. But federation is the big agenda going forward. Is probably the big change that is going to come. And we're again working with many of the colleagues that are physically in the room with you today as part of a big national consortium. We have produced 120 pages of absolute indulgent fun about the definition of federation. It's horrendous to read, but it's very good to have a very formal definition, and we're working around that to kind of create systems. So as I think Phil touched on it earlier, there was a proof of concept that happened in the last 2 years, and we built these 2 systems to kind of show the art of the possible. And we had an eyes-off process, which we called, eyes-on process, which is called Teleport. And this is conceptually where we create a pop-up trusted research environment between trusted research environments to act as a common place with a consistent capability, consistent governance, and consistent user experience. And the idea was that all of the partner trusted research environments have common command and control over that trusted research environment. And then all of the trusted research environments were interconnected using a polystore database or lakehouse to calibrate, saying, a single pane of glass view to the researchers, and the fact that the databases are distributed and in different trusted research environments is, well, irrelevant to the researcher. It's obviously relevant to trusted research and relevant to the information governance people, but it's irrelevant to the end user for that user experience. We also worked on a completely different tangential approach, which was an eyes-off model, which is based on global GA4GH TES. We heard from South Africa a minute ago that they're using WES. It's very, very similar. This is where you go to what we call a submission layer or an API, submit your payload, and we deal with all of the 5 safes. So that is an international standard, but what we've done is we've dealt with the safe people, the safe environments, safe data, and so on and so forth. That sends the query out, it gets executed, and it gets egressed back, and you get the results back in. User experience is very different. You have to write code a little bit like this. It's about writing containers, which is obviously a very different experience, but you can write a workflow to do anything. And because you can send in containers, actually that's an advantage because it creates complete consistency between the trusted research environments. It doesn't really matter whether one trusted research environment supports Python or R and the other one supports Stata. You package whatever it is you need to do your science and send it in, and it will run consistently in all of the trusted research environments. So I think that's really important. Federated learning, we're doing 12 federated learning projects. There's nothing wrong with federated learning, it's all fantastic. The problem is that this area in the middle where the update and the updated parameters happen, there's not possible to do an egress. And of course, most trusted research environments really like to egress data. That's their main line of defense. So this is a real problem with information governance. So we're working with in the next phase about how we mix and match. How do we get these model aggregators into, say, a pop-up TRE so that actually we can have that sort of safe transition? Because the teleport basically allowed the data to move around, and then you had the delayed egress. That is exactly the sort of model you need for federated learning. So that brings me on to my last slide, and that's, again, working with Phil in the room about the next phase of federation. And there's this thing called Treevolution, which I haven't got time to go over today, but we're working on infrastructure to basically coordinate all of the trusted research environments together, to form consortiums across trusted research environments, and to handle the deployment of all of the software that is needed to kind of support federation. We know there is no one size fits all, and that we are going to support the ability to deploy Teleport or Trifix, not a problem, but also Data Shield, Vantage 6, Flower AI. We need to basically do the plumbing for all of this kind of software that we see out there that the researchers want to use. It's not our decision about what the software should be, but we do need to make sure all of the 5 safes are encompassed in that. And as part of that program, we're also looking at semi-automated output checking, and we're also looking at a formal specification for a trusted research environment, again, to help people reach a level of maturity across the ecosystem. So I think what we're really defining here, working really hard as part of the consortium, is to really define the trusted research environment of tomorrow. We've already got the one for today, but it's going to look very different tomorrow. And that's all I got.
Simon, thank you very much indeed. Okay, final presentation, and then we'll move on to panel discussion. So I'd like to invite to the stage Professor Neerja Karnani, forgive me, sorry, I practiced it all day. Deputy Director and Precision Health Programme Lead, Bioinformatics Institute at A-Star, and an Adjunct Associate Professor at the National University of Singapore's Yong Lu Lin School of Medicine. So please, Professor Karnani, please, the floor is yours.
Thank you, Esmond. Good afternoon, everyone, and thanks to the session organizers to give us an opportunity to share the Singapore's perspective of data science. So Singapore, also known as the little red dot, is a small nation which is a home to diverse Asian population of 6 million, and its healthcare system is divided into 3 health clusters covering 11 different public hospitals. Now, even though Singapore has a great healthcare system, which is universally applicable to everyone, still Singapore is facing rising concerns of health scenarios, specifically in the areas of cardiometabolic risk, cancer, as well as an aging population. And to top it all, the healthcare spending is expected to hit 30 billion a year by 2030. So Singapore is trying its hardest to bring down the healthcare cost, and one of the approaches there is to launch the Precision Health Program, which is basically integrating prevention, diagnosis, and treatment across different stages of life course, but then with an Asian-centric mindset. And so to do all this, there's requirement of data, a lot of data, and across different modalities. And so when we talk about different modalities, it could be coming from deeply phenotyped research cohorts, electronic health records, as well as real-world data, and then this data needs to be AI-ready. And as a return of investment, and so much of the infrastructure that is going into the data sciences is to make sure that the projects are mission-driven. For example, they need to have a clinical deployment, or they have to have an impact on society through policies or many other ways in the economy. So like every country, Singapore is also preparing its national biomedical data framework, which is centered around building strong, robust data infrastructures with interoperability, develop as well as test different federated analytics tools. And then while the local system is evolving, there is also a high intent in developing enablers that allow cross-border data analytics. And so what does the Singapore's biomedical data ecosystem look like? We have 2 types of data sets, like highly sensitive on the extreme left, which is coming from the public government health resources. And here we have data on the Ministry of Health, Health Promotion Board, or then from government admin side, that is on socioeconomic status, that is the Housing Development Board, the insurance. And so there's a lot of sensitive data there. And then we have on the right side is the research data, which is being produced either in hospital setting or in research organizations. And then this research data is actually put into a research data node under different specialized platforms. For example, A-STAR has a biomedical data hub for just the cohorts, where we have like specific ISO certified sandboxes for each cohort. Then for National Genomics Program, we have the PRECISE platform. And so we have these different dedicated platforms, but the most important thing is that we also have a national data exchange called as TRUST. This is where the sensitive data meets the research data, and there's a linkage that is possible there, and you can run the analysis in a secure cloud analytics environment. This also uses the 5 SAFEs approach. We also have the Biomedical and Health Standards Committee on developing national standards for health informatics as well as genomic informatics, which was just recently started to harmonize different capabilities and data nodes. So there is a national data curation team. This is being developed in partnership, as a partnership between the TRUST, which is from Ministry of Health, as well as a Bioinformatics Institute at A-STAR. And the purpose here is to support and uplift local data ecosystem in terms of data quality as well as interoperability. Of course, we've been using the OMAP standards, and then our work is well recognized by the ARDC scientific committee. We're also working with our collaborators in UK on CARET, as well as letters that you heard earlier. And then coming to data security, so there are efforts going on. I won't say like we are there. We're testing, developing new things, as well as testing what is available in the ecosystem. But here is a suite of privacy enhancing technologies that was developed by our cybersecurity team at the Institute for Infocom Research in A-STAR. The suite is very conveniently called as PETSU, the reason being that it has various digital creatures like panda, panther, and penguin that are being designed to make the data analysis secure, and this is by encryption, anonymizing, or by isolation of the computation. The another thing that we are testing is synthetic data. And this is a collaboration with Datacebo. Datacebo is it's a spin-out from MIT, and we're working with them in doing synthetic data generation for clinical data sets and then applying that to AI-based risk models. It's just a use case we've been doing on cardiovascular disease risk, and we've also been doing it on diabetes and testing the performance of this. So this is an evolving space that we're very keen to develop further. So if we invest so much in our data infrastructure, there is a return on investment expected. And so we look for solutions that are coming out of all this. And so the first one, for example, here is we built a data infrastructure which is actually a daily infectious disease surveillance system for 10 local hospitals. Literally every day insights come into this database. We've created an omnibus. This is a mobile application, suits of AI health coaches to support different cohort studies, as well as staying more connected with our patients and our subject volunteers. We built AI, used AI, the agentic AI in surgical counseling clinic. We've been using LLM models to track longitudinal EHR data on disease basis, or we've been using AI for diagnosis and screening, for example, in case of digital pathology. So just a few, I mean, there are many which are ongoing, but we are also very mindful that we need to broaden our avenues of data analysis across the border, and we face the same core challenges we've been hearing all throughout during the International Data Week and in this session. And so the real way to tackle it is go ahead and develop some use cases and test it out. And this is what we've been doing. We joined HealthWise, and this was in last year in May 2024. As a group of like everyone having the same mindset of approaching this problem, trying to figure out some funds and bring the tools to table. And so as an extension to that, in effect, was that we signed an MOU between the Ministry of Health Trust, A*STAR, as well as the Universities of Nottingham and Swansea in October 2024. We developed 2 use cases on cancer as well as type 2 diabetes to test Bunny and Tess. So this is a classic example of trying other tools, tools available internationally in our local ecosystem. And then just before coming to this International Data Week, we just had a workshop to have also momentum in our collaboration and having a cross-learning. So beyond HealthWise, we are further growing our network of international data interoperability. For example, we've been doing it in the United States with Sutter Health, Cedars-Sinai, and then we recently received a Wellcome Discovery Award, which again is to develop interoperable data analytics between University of Cambridge, Wellcome Sanger, and A*STAR in Singapore. Industry collaborations is another thing. We keep looking for methods coming from them. So we develop an A*STAR BC Platforms joint lab to develop as well as test out their mechanisms. And then you already heard about the Datacebo. So I'm going to stop here with my last slide, but of the most important people I represent and different local public agencies from Singapore who've been doing all this phenomenal work, our collaborations with HDI UK and HealthWise. And yes, we're hiring, so anybody interested to approach us. And we look forward to collaborations. Thank you.
Okay, Neerja, really, thank you very much indeed. Okay, I'd like to invite those who presented up to the front, and if we could have the 2 virtual attendees on screen as well, please, for the Q&A, that would be wonderful, thank you. Are there any questions? Thoughts, questions, comments? I'll do it then. Oh, we need, oh, right, okay. That's right, okay, we'll figure it out.
Thank you, really interesting. So I work in agriculture and environmental data, so completely out of my context, but the the title of the kind of session was the highs and the lows. And if I listened to the talks, they all sounded really, really positive. So I've had plenty of war stories, so I'd love to hear some real lows actually, so something that I can relate to.
Hello. Yeah. Simon, you're good at telling lows. Do you know?
No, when you have enthusiasm and optimism, there are no lows. There are unbelievable barriers that are irrational in front of you, and I think really it's about navigating those. And I think when I was a young man, I used to fight them too much, and now I work around them and with them and respect them. I think you mentioned agriculture. I think some of the geospatial stuff I think is absolutely fantastic, really, really fantastic. And we do a lot. Well, I don't do it, but my colleagues do a lot of it. There's a big information governance risk to doing that, but it is possible. We have done studies of how close you are to an off license or a green space, and how your outcome, how your health outcome is affected. But we've done it in a privacy preserving way, which means actually there's no problem. You can have all the data and you can carry on with your science. It's just an extra level of complexity that, again, if you embrace, it's easy to solve. If we get cross about it, we don't never find the real answer.
I think that's a guide to life, isn't it, surely? Other questions, please.
Thanks so much, everyone. This was a wonderful set of presentations. So Christine from UNT, and I'm curious if you have all encountered a need from the lawyers. You mentioned legal complexity in contracts, but has there been a need for accountability in terms of where that data is going, what transactions it's being used for? In particular, I'm curious if you've integrated any of the data space elements coming out from the data space protocol, because I know that's something that's been emergent in the same time frame.
Yeah, so I think what's hard in this space, that's partly why we try to refer to it now as federated research rather than just federated analytics, is because there's so many different things that are going on. So short answer is yes, but it's actually really hard to understand how to assemble it all because there's so much different activity that's going on. So, you know, Simon referred to our 101 odd page blueprint, that was by Dare UK. You'll be pleased to know there's another one from Entrust, right, which is similar but not quite the same blueprint, which is also linked to European Health Data Space Programme. So there's so many initiatives going on, and it is then it's actually how does it go. I think Simon hinted at then the change that's needed in the attitude of when you do disclosure control. So not if, but when. And so when you're in a federation of multiple TREs, this idea that the normal approach to disclosure control will still work is hard to maintain, but it's trusting somebody else to do that disclosure control on your behalf. So it's that slight change of the model, still compliant to all the principles, but how do you adjust to do something? And that's why we've been doing a bit of work actually to understand the trust levels between TREs, because it's not a technical solution. The technical part is dead easy, right? And that's why we refer to it as possible, useful, and acceptable, because one defines the other in lots of ways.
Okay, no questions online. Any further questions, ladies, gents, people? Please, David.
Hi, yeah, that was a very interesting set of presentations. I just have a question on TREs, and it's more a technical question. Have you looked at semantic web formats in terms of storing the data? Because I can see certain advantages in terms of federating queries across. I picked up from this a lot of the federated queries were done using standardized data sets with OMOP. I didn't get all the details, but so I suspect there's quite a bit of transformation going on in the background. Anyway, I throw that open to the panel.
Simon, question for you, perhaps?
Yeah, I mean, so we have looked at it. I think the issue really is confounded by the modality of the data also, in the sense that for EHR data, you know, we give the raw version, we give the clean version, we give the common data model version, and we also maybe give specialist views of the data. Why not give another one like a semantic web-enabled version of the data? This is not a problem, but I think when we get to genomics, imaging, NLP, bioinformatics, this is where there are loads of standards, but they're all very different in the modalities, and perhaps that's a bit of a barrier. I think perhaps EHR data and imaging data are more mature or more ready for federation. So again, you know, maybe just stick with those modalities and look for these sort of things. But I think what we need to do is transition to this. We're all running trusted research environments, delivering a set of value to our set of researchers. We're not coming together currently, and we're asking them to come together. And when we come together, you have to adopt the same standards. When you're not together, you just need to give you need to give it any standard and explain that standard to someone so they can do science. And I think this is the new challenge, because it's a very costly activity to convert to a common data model or adopt something like a semantic web approach. There has to be enough return on investment. In other words, science has to be accelerated because you've done that investment. And that, at the moment, the business model is not clear, because we're in a chicken-egg situation of we're not doing huge federation across the world today. So we haven't really got a problem today, but we need to make an investment for tomorrow. I don't know if that answers your question. That was my best effort.
Okay, yeah, to me, the ability to mix all this multimodal data together, whilst I predominantly currently work on OMOP, it's just a flavour of common data model. So if you could bring these multiple types of data together, for me as a non-healthcare person, clinician, etc., even in my limited view of things, I think that could be really game-changing, life-changing, etc., incredibly powerful. Okay, any further questions? No? Yes, please.
In the repository world, there's a thing called the core trust seal that's sort of a way of judging this as a trustable repository. And I think the scenario for that was publishers saying, well, okay, if you're publishing, then put your data into a repository, but what is a good repository? And there was a seal thing there. Only a metaphor, but I'm just wondering whether you see there's any pathway for a kind of mutual recognition system for TREs, and what that might, what the steps towards that might be, what it might involve. Another sort of metaphor for that is in Australia we have a mutual recognition system of ethics approvals, where if it's been approved by one, and that also runs on a sort of a set of certified qualities. So anyway, just wondering about any steps you think we could take towards such a system.
Yeah, so there is the SATRE specification, spelled S-A-T-R-E. So that's come out of the DARE program. In previous rounds, and it's still going on, it's part of the Treevolution program as well. And that is a self-assessment tool, but it's a way of kind of assessing yourself against criteria. And we're currently working, it's the wider team, so it's based from University of Dundee. They're now looking at what that specification would mean in a federated sense as well. So it is a way of benchmarking a little bit between entities. It's not an accreditation, but it is a self-assessment way of kind of going, here are the components we think are important for a TRE to be able to evidence, assess yourself against it. And obviously there's the very formal ISO standards around security and processes and those types of things. We also have different regulations. I mean, do you want to pick up anything from Australia?
No, I don't, but I think we have busy TRE in Australia, and I think the idea of self-evaluation with SATRE is very appealing. Yeah.
I believe we have a question over there. Yep, please.
Steve McEachran, UK Data Service, formerly Australian Data Archive. I want to pick up on Adrian's question. So as a quick response to this, the UK Data Service is doing a bit of the evaluation of SATRE and SACRO to see, to get into that, those sort of questions. of, I think you're right that there is probably an accreditation module that could come from that. One of the interesting things is if you take the 5 safes, the starting point here is it's essentially an instantiation of the safe setting. And what is it that you're instantiating there is really the question, that kind of comes into the mix there. So that's one of the discussions there. So UKDS has Core Trust Seal and ISO accreditation, and we're doing the mappings as part of a DARE-funded project. So I think more to follow on that one. My question to colleagues is picking up on, in a sense, what we've seen here today. UKDS and the work I did here is social science rather than health science. To what extent are we able, and this is part of my role, is to help in this process, to what extent are we dependent upon what if I'm not a health researcher and what if I don't have a health project? How transferable are the sorts of approaches that we're looking into here on essentially a model that starts from health? That's important. I think it's an important sort of part of the equation here.
In our case, what we've experienced as I myself am a researcher, and honestly, a lot of frustration led to joining this whole community of federated analytics and making things easier. Even doing a simple project between 2 countries, the collaboration agreements take 3 years. It ends, the funding money ends, and the collaboration agreement is not yet done. And so our objective has been to make things more visible to the researchers as we are developing this whole community mindset of, one, not work as silos and be fragmented. So if you are open and you bring our data sets and you deposit in these repositories, then you can access the systems and the methods. So it's more democratized. But at the same time, it is also a top-down approach, because we realized even though we tried doing this effort, it was futile till the government intervened and there were policies being made, there were structures, data structures being made where there was the sense of belonging and the need that was brought up in the system. So yes, it is democratization, literacy of the researchers, and the call to cause, you have to be a citizen of it.
Come in on that.
Go on, Simon. Yep.
I think it's a great question. I think it's not about health at all. I think health is just more mature and more acclimatized to sharing, if I'm being honest. So, obviously, as I said, we've got non-health, we've got tax returns, education, data, criminal justice, etc. It's really about everything that affects a person, because health, it doesn't happen in isolation. Your social economic circumstances affect your health more than anything else. So I think a lot of us are trying to shine a light on any and all data sets, including environmental, climate, everything about a person, to kind of create that richest possible data model for researchers to kind of find out that causal effect about a life outcome. And life outcome as well is not just health. I mean, in the ADR UK platform, it is about whether or not you become socially disadvantaged, or your opportunities are different, or you're back, lots of that is part of this. We do have one TRE that's about to be funded, which is all about cows. But that's kind of, but in that instance, it's about microbial infection between agriculture and humans. So it's still, human focus really.
And one last one on that. I think it's really important around the adoption of standards aspect is not to be too drawn from where the standards started, but how applicable it is to the domain. So we started, we're in trusted research environments and EHR data, but we're taking standards from GA4GH, which is genomic data, but it's not our, it wouldn't be, we could easily say, well, that's genomics data, not ours, we'll start something new. And FAIR didn't really initiate from that same community. So it really, that's why we're really trying to focus on the adoption of standards, understand, well, what was the problem they were trying to solve? And is that the same problem we've got, even if it's not the same domain?
Yes, please, thank you. Got time for 2 more questions?
Nice talk. Robert Shen from RMIT University. My question is about the data ownership. Do you mind comment on this type of who owns this type of sensitive data? In particular, if you facing scenario like a patient who want to remove part of the data set, what sort of process?
In the case of Queensland and the IMR, the owner is Queensland Health. And we have agreement with Queensland Health to access the data under given conditions. But they are the owner.
So we think like data is more like a community asset. Like, end of the day, the owner is the individual. And the custodians are all these, groups that are either producing on the samples or holding the data. So that kind of a mindset is what is critical in as a working model of the societal belonging of the data and its use and its democratization.
Sumir, are you online?
Yes.
Yes.
For us in DSI Africa, it's a bit more complicated because each of the research hubs are funded institutions. So each of them have their own ethics and their own data access committee. So one of the reasons we're trying to map to data use ontologies is to try and automate the data access requests. If you can do that with the data use research identities and using the broad DUO system. But in our case, we don't have a centralized data access committee. It's each of the projects have control and they have their own ethics committee that reviews that.
And just one quick thing to add. So in HealthWise, the equity was also about equity of access. So it can't just be that when we develop these solutions from Nottingham, it's about our researchers getting access to other people's data in that helicopter science type approach, but also how do we give people equal access to UK data sets? It's got to work both ways if it's going to sustain.
Volmar from Elixir Sweden. I was wondering, how far have you come in terms of being able to cite and provide mechanisms for reproducibility when it comes to federated analytics and combinations of various different data sets? Are there any standards for referencing the data as it was at the time? Or?
Yes, Simon, do you want to pick that up? I think you've got DOIs, don't you?
Yeah. So we have DOIs in reference to data sets and specific versions of data sets and so on and so forth. And that's reasonably mature in the UK. It's not consistent, but we're working on how to make it consistent across partners. The other thing is that we are adopting RO crates as a mechanism of providing that audit about what happened to what, when, how, and why. And obviously, RO crates are fundamentally about reusability. But I think it's a different area. Trusted research environments are a different area than perhaps their origin, if you like, because the data is never going to leave the trusted research environment. So it is about describing the state of the data at that given time and being able to rehydrate that data at any given time. We're lucky in the UK that actually, if you do science in a trusted research environment, we have to keep the data in its current state for 10 years. So actually, legally, we have to maintain the state of the data that we gave you at any moment. So we're inherently more reusable. Reusability, I think, is less mature than in other sectors, though.
Okay, we're at time, so I'd like to ask everyone to put their hands together for everyone that's presented. Thank you very much. Thank you to everyone that's presented. Thank you for your attendance. It's been lovely to see you here, and thank you for your questions. And please feel free to ask us questions afterwards. Us at Nottingham, we're here next week as well at the eResearch conference, so please come say hello, chat to us. We're always happy to discuss things. So once again, thank you all very much. Enjoy the rest of the conference. Thank you.